Hello students, and welcome to the CompTIA Tech Plus exam course brought to you by Third Level Technology. I am your instructor, Jim Herbie. In this episode, we're going to continue in Module 4 of the exam objectives and discuss Section 4.3. Our topic is Programming Concepts. Let's begin.
The first programming concept we're going to discuss are identifiers. Identifiers are a technique we use in our program code to give names to specific elements within the computer program. Your identifiers will be a string of characters that will help to describe the type of element that they are using within the program. There are several different types of elements that we use with identifiers. We use identifiers with program variables, functions, and arrays. We'll discuss each of these three in more detail as we go through the episode. When naming an identifier, there are some best practices you should use. First, you should make sure that the first character in your identifier name is either a letter or an underscore. You typically don't want to use numerical values in your identifier names because many times the values that will be contained within specific program elements will have a numerical value. A lot of times we will be doing mathematical functions and expressions, and it's best practice to use letters or the underscore symbol. Your identifier names should also contain no commas or blank spaces. Many of your programming languages will also have a 30-character maximum in the name that you give to specific elements. You also should be aware that there is a distinction between upper and lowercase letters. If you use any type of uppercase letters in your identifiers, you want to make sure that when we declare or refer back to them in the program, that they also have the same lettering structure. A program will not execute properly if we use lowercase letters in place of their uppercase identifier nomenclature. Next, we're going to discuss containers. Containers are a data structure within our computer program that allows us to create groups of what we call objects. Objects will be specific instances of what we call a class. Your objects will be individual components or elements within a class. The class will be a grouping of objects that will have some type of common characteristic or feature. Your containers can take a couple different structures. The first type of container is a single value container. A single value container is one where each object that we have contained within will be independent from each other. We also have associative containers when we want to find the value of a specific object stored within a container. We use associative containers with arrays and functions. You want to make sure that as you're going through each element of a program, that you understand the basic features of what they do. First, we're going to discuss a variable. A variable is a name that we give within a computer program to store a specific value. We use variables to describe the stored values contained within. Let's say within your computer program, you want to create a variable called number. We can create a variable name by spelling out the word number. Then we also want to determine what data type do we want to use with this variable. Because we are using a number, which is a numerical value, we can use the data type of an integer. We abbreviate that as int. So we can create a variable beginning with the data type of int for integer, a space, and then the variable name, in this case, number. Then we would put an equal sign and then assign a numerical value. Variable names should describe the stored value within. This will help us to identify what types of information are going to appear within our computer program. The process of creating variables in a program is called a declaration or declaring. This is the process of being able to identify where variables appear within our code. We also want to understand constants. Constants are variables we create in a program that cannot be changed or modified once they are declared. Many times you may be using variables that include mathematical expressions. And depending on the value that is inputted into that function, it will return a different value. With a constant, we can create a variable where the value will be the same throughout the entirety of our computer program. Next, we're going to discuss arrays. Arrays are a data structure we use in our computer program to store a fixed size collection of elements. Within an array, we will have the same data type throughout. Arrays are most commonly used with numerical values. When we create an array, we do so by separating each individual element with a comma. When we create an array, we can identify different locations within by using a feature called zero-based indexing. This is the process of being able to identify a specific element within an array. In an array, we use zero-based. So the first element that is contained within your array will have an index value of 0. And as you go through the array, each individual element will go up 1 in numerical value. So you'll begin with 0, 1, 2, 3, 4, and so on. Return a value within an array by specifying the index number. So for example, if we wanted to identify a numerical value in the second indexing place within an array, we can use the declaration of int for integer, the array name, and then in brackets, we can put the numerical value of the index spot that we want to return the value for. Let's contrast that with a vector. A vector is a data structure that allows us to increase or decrease the length of a data type within a single container. Arrays will have a fixed length. Once we create an array, the indexing value will be the same throughout the program. With vectors, we can have a dynamic structure where we can increase or decrease the amount of elements contained within, depending on the needs of our program. The next programming concept we're going to discuss are classes and objects. These are a very important programming type because they allow us to create specific elements within a group. You want to understand classes, objects, and instances. A class within a program code is going to be the name we give to the group of individual objects. The objects will be all of the individual data types or components contained within a class. Your instances will be when we identify one specific individual object within the class. Let's use an example. Let's say I want to create a class within my program code for education levels. This will be how far did a user go in their education journey. The class will be education levels, and the objects within the class, high school diploma, college degree, master's degree. These would be examples of objects within the class of education levels. And we can use an instance to identify individual objects within the class. So we could return an instance for college degree. That is one individual object within the class. This is a very effective structure type to allow our developers and our programmers to group multiple elements within a single grouping or class. Next, we're going to discuss properties. Properties are going to be the attributes and behaviors that we assign to the objects within a class. Attributes will be defined characteristics that allow us to delineate or distinguish each individual object. One example can be creating a class for person. And all of the objects that will be within that class, such as age, gender, height, hair color, and others, would be specific attributes of the defined data class. We also can use behaviors. Behaviors will be tasks that our objects can perform during execution of a computer program. that will be things that are going to be executed within the program as we go through each of the sequential code steps. We also want to understand functions. Functions are sections of code in a program that will perform a specific task or equation and return a value. One type of function is a method. A method is when we create pre-written functions that can be accessible in our program through a method library. The method library will be the location where our code can go and access all of the different functions and mathematical expressions that will be completed within our program code. You also want to understand procedures. Procedures will be sections of code that will perform a task but will not return a value. It is a way that we can create and prep our code to be able to return values for our functions and our methods. The most common use case for functions are mathematical and algebraic expressions.
That will conclude our discussion of Section 4.3, Programming Concepts. In our next episode, we'll move on to Section 4.4 in the objectives and discuss organization and logic. We thank you again for following along in the episodes and the course, and wish you best of luck in your studies. Enjoy the rest of your day.